I'm Mark Spossler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 23rd.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we don't see a whole lot going on. Little area of disturbed weather generating 20-foot seas in the Southeast Pacific. Another area under New Zealand doing about the same thing. And another system north of New Zealand. But none of these are effective swell producers at this point in time. Let's go take a look at the upper levels of the atmosphere. But before we get started on that, a quick apology. We tried to make the video last week. We tried 4 times. The computer crashed 4 times. It was about 20 minutes into it each time and lost everything. So, and by the 4th time, I pretty much gave up and said, well, we'll just give the computer a break. It's an older machine. We got a new one on order. But so far this week, things appear to be stable. So here we go again. All right. As usual, we'll start off looking at upper level winds. These winds, jet stream level, are about 30,000 feet, and they help support gale formation. When you have a trough, that is a dip in the jet. In this case, it actually dips towards the equator. So it's really kind of a peak like that, just like there. That helps create a clockwise flow aloft and down at the ocean surface. That is the hallmark of low pressure. And if the low pressure is deep enough, it generates winds. If the winds are strong enough, they generate seas. If the seas are high enough as they radiate away from the fetch area, they turn into swell. And of course, swell, when it hits your beach, turns into surf. So we're very interested in troughs. They are the things that set everything up. So we have a little trough here under New Zealand being fed by 130 knot winds. Not super productive at the moment. And then there is kind of a trough here, but it's completely cut off. You see the flow going underneath there. It almost looks like it's really a split jet stream flow. But this pattern is what has been feeding gale development in the Southeast Pacific. So we're keeping our eyes on it. All right, let's put this into motion, see what happens. As we get deeper into Sunday and into early Monday, the trough continues southeast of New Zealand, but it starts weakening. Noticing winds getting much weaker. Other than that, we have this big ridge here over the Southeast Pacific. That does nothing to support gale formation. But you watch this trough as we get into Monday night and Tuesday, and it's not even really a trough, it's just this little nook right here on the leading edge with a ridge on the back side of it. And notice the northern branch of the jet stream running right along here. As we get into Wednesday, look at this. The southern branch goes the whole way up, meets the northern branch, starts, let's see if we can get this, creates a pocket of 100 and, well, there we go. There's about 170 knot winds. That continues into Wednesday night and Thursday. You get this nice little hook thing starting to develop here. There you go. Pretty obvious. And that will be very supportive of gale development. And the models are projecting some sort of significant storm from this. The interesting part about it is if it forms, it's going to be way up at like 35 or 40 south, which is a lot closer to California than if it developed down at 60 or 70 south. So for every 10 degrees north you go, that's 600 nautical miles closer to California. So if instead of being at 60, it's up at 40 or even 35, then you're talking 1,200 nautical miles closer. That reduces swell decay as it radiates up to the north and just ensures more size of whatever swell does get produced. All right, so that trough, now interesting thing, the trough starts falling south on Friday. Most of the energy then takes aim at, we'll say, Peru and even more so Chile. And then as you get into Saturday, it kind of all just falls apart. No real wind energy pushing under New Zealand, and a quiet pattern sets up, at least aloft. All right, let's go take a look down at the surface. Here we are, surface level wind, surface level pressure, and as expected, there's this weak, persistent low pressure system here in the southeast Pacific. This has what has generated, or the remnants of this right now, is what has generated swell that's hitting California at this moment. That swell's actually fading out. A lot of local wind, both north and southern California, didn't make for ideal conditions until today, but you know, in Southern California, things have cleaned up. Northern California is still pretty much a mess. Another low-pressure system under New Zealand with 35-knot winds as expected. Building to 45 knots this evening, aimed pretty well to the north, and then quickly falling apart as we get into Monday. And then on Tuesday, another low-pressure system tries to build southeast of New Zealand. This is the interesting thing. That trough starts developing around here. And as we get, there you go, you can see it. It's right under, unfortunately. I'll click away here. Right there. You see, whoops, there we go, 45 to 50 knot winds. And there, there we go. 55 knot winds on Wednesday night, aimed pretty well to the north with a broad fetch of 30, and then you got 50, 55 knot winds all in this area, and the Southern California cutoff about 118 west. Okay, that's where Southern California is. Northern California about 122 west. All this is in the swell window. But again, it sort of sets us up for this very south-angled kind of swell pattern, which seems to be the dominant type of trend or style or whatever you want to call it for this summer season. Anyway, as we get into Thursday, now notice the low. We'll go back here. It's still producing south winds, but the low itself starts falling southeast, still in the California swell window, building fetch as we get into Thursday night. Then Friday, and then everything takes aim at Chile there. There is some fetch here over on the west side of the storm, but most of it's on the north side, all aimed at, we'll say, anywhere from Peru down to Chile. And then you see most fetch taking aim at Antarctica as we get into Friday night. Saturday, that thing is pretty much gone, and then we move into a far weaker pattern as we get into a week out from now. Let's go take a look and see what effect those winds are going to have on the ocean surface. But before we do that, we're going back almost a week till Monday night last week. A little gale developed under New Zealand. Nothing particularly strong. What was that? 26, 27 foot seas, we'll say. Then it built a little bit as we got into Wednesday with 34 foot seas over a small area aimed well to the northeast, and then fading. And then pushed east a little bit into Thursday and Friday, tried to organize. Now notice there were some seas here, but they were all aimed southeast at Antarctica, so we're ignoring that. Pretty much this system faded out. The net result is there is swell in the water radiating north towards California, and that swell should arrive about midweek. Actually, later week. I think it was Thursday for Northern California. In fact, here's the peak period chart. This is all energy. It gets rid of all the short period, 13 seconds or above. This is the front right here. You can see the swell with, what's the purple? Purple about 18-second period. No indication of size, just period. Pushing up into California, and you can sort of imagine it somewhere right around there. So that's Wednesday evening, Thursday, into the latter part of the work week, fading. And then another system, the next longer period, what is this? 1, 2, 3, 4. 1, 2, 3, 4. So we'll say 22-second period as we get into Sunday the 30th. Whoops, that's as far as we go. That's 180 hours. Pushing into Chile, poised for Mexico and Hawaii. You get the general idea, but be clear. The storm that's making this swell has not even formed yet. It'll be a couple of days still, so this is all just voodoo. It's a figment in the imagination of the model. It is not real yet. All right, so looking forward, we have one swell we know is in the water, originated from, we'll say, east of New Zealand. And then we're keeping our eyes down in this area, moving up into this area from low pressure that's supposed to be developing. So we get into Wednesday, and pretty much right on cue, there it is, Wednesday night. Small area of 37-foot seas building to 42 feet late Wednesday night. continuing at 46 feet early Thursday morning. Now notice it's not a huge area. It's a very small area fanning out over a pretty broad swath here. And then the seas themselves falling southeast, most of the energy aimed east as we get into Thursday night and Friday, and then all energy falling southeast. Still chilly, we should get a significant bout of swell from this, and then it's bound for south of the 40s and of no interest to us, and a quieter pattern sets up. So basically, one swell in the water, another gale, forecast behind that, hopefully producing swell aimed well to the north, but really focusing on California, Hawaii pretty much out of the picture, since this is again one of these very southeast Pacific type storms. And that's typically what happens during La Nina years. It seems like all the focus is over here. During El Nino years in the summer, the focus is over here. And so pretty much textbook type scenario this year playing out. But not to be left out, Sunday, a small gale, believe it or not, or we'll call it a low pressure system over the North Dateline region, producing 19-foot seas, and that's about all it's going to do, falling apart. This will provide some, we're talking minimal, like 2 feet at 12-second period swell for Hawaii, but something to be aware of. And then another one is forecast behind that, and even a little bit stronger further south, aimed a little bit better at the islands on Thursday. Again, 21-foot seas, and then fading out on the dateline. But even 16-foot seas into Saturday night. So sort of a swath of energy. Again, maybe some small 2-foot type swell for the north-facing shores of the Hawaiian Islands. Then maybe another behind that, which is kind of odd given that we're into May, but not out of the question. It happens. And then a quick look, wind swell potential. All right, as of right now, 12C Sunday is the latest run of the model. Weak high pressure, 1028 millibars, still generating northwest winds along exposed northern California coast. 15 knots in pockets. It's stronger that in some places in northern California for sure. But in general, nothing that's particularly adept at producing wind swell. You really need 15-knot winds over a pretty decent size area. Also, like here, more relative to Hawaii, a broader patch of 15-knot east trades pushing at the Hawaiian Islands, maybe generating some easterly wind swell in a day or so. As we get into Monday, high pressure, notice starting to take up a broader area filling the Gulf of Alaska. Northwest winds build 15 to 20 knots along the California coast. Still not super adept at producing wind swell, but maybe some wind swell, mainly down into central California. A little bit of trade still persisting east of the Hawaiian Islands, making for some wind swell. Tuesday, it looks like the gradient maybe tries to get a bit better organized with 25, 30-knot winds. Also notice low pressure trying to organize here in the Gulf of Alaska. We've seen this before on the models, and then every day as you get closer, the low just completely disappears, so we're not holding our breath on this at all. Anyway, northwest winds, 20, 25 knots at Tuesday night. Wind swell for sure being produced relative to California. Wednesday, the low builds to gale status, 35-knot winds pushing up along the coast. Hard to believe. Still high pressure producing some wind swell for California. Thursday, the low moves into the Pacific Northwest. That sort of cuts the legs out of the high. Wind swell dropping, but maybe there'll be some wind swell from this system if it materializes. And then as we get into Friday, high pressure starts rebuilding. 20, 25 knot northwest winds along the California coast. More wind swell possibly to result. Saturday, notice this low pressure here in the Gulf. That's the same one that's going to make supposed swell for Hawaii, small swell. Again, 20, good size fetch of 20, 25 knot winds for California on Saturday. More wind swell. And Sunday, pretty much the same, though less winds along the immediate coast. So the short of it is some minimal wind swell initially in the next day or two, but then slowly ramping up as we get towards the weekend. Seeing that it's May, seeing that all the ski resorts are closed, seeing that the snow is melting fast above 8,000 feet and even above 9,000 feet, And no snow is in the forecast, so we're going to let that go, and the season is over. And no rain is forecast for California. We did look. So let's go focus long term. What's going on with the Madden-Julian oscillation, and of course the El Nino Southern oscillation. So we're very focused on the MJO. It's this periodic weather oscillation. There's two phases to the MJO, the active phase and the inactive phase. The active phase is the one we're interested in because what it does is imparts energy to the jet stream, which in turn feeds the storm track, which in turn, of course, produces surf. What it also does is creates or can create westerly winds, can dampen trades in the West Pacific. When that happens, it can take warm water that's in the West Pacific, start pushing it east in the form of what's known as a Kelvin wave, a ball of warm water that travels under the equator from the West Pacific to the East Pacific. It takes about 3 months to make that journey, and when that warm water erupts off of Ecuador, then it warms water temperatures there, and that can theoretically change the global jet stream circulation. And if you get multiple Kelvin waves driven by multiple strong active phases, the MJ in the Pacific, that can usher in El Nino. We don't see that happening at the moment. But what we do see is a Kelvin wave in flight. We're going to get into that in a minute. And a change from what was a pretty solid La Nina pattern this past winter to what appears to be a transition to an ENSO neutral pattern. Neither El Nino nor La Nina, just somewhere in between. So we're going to be talking about that in the next few minutes. All right. So first off, winds. We're looking for signs of the active or the inactive phase of the MJO. This is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here. This is the West Pacific here. That's the equator right there. That's New Guinea there. Ecuador and all that is just off the chart here over to the right. We're looking at the arrows. Long arrows mean, and these are 5-day average winds, means pretty strong easterly winds over the East Pacific, pretty strong easterly winds over the Central Pacific, and the West Pacific here. We call it the Kelvin wave generation area because if you get the active phase of the MJO over here and it produces westerly anomalies, that produces Kelvin waves. So we're very interested in what the winds are doing in this area. And right now, we see pretty strong easterly anomalies, pretty strong easterly winds, meaning probably no sign of the active phase of the MJO. But it's not the actual wind speeds, it's the difference from normal for this time of year. This time of year, trades are pretty strong in the springtime, pretty strong over the equatorial Pacific. So looking here, we see these little baby arrows pointing off to the west, meaning, yeah, the winds are pretty strong out of the east, and they're abnormally strong, not a lot, but a little bit stronger than normal over the East Pacific, about the same over the Central Pacific. In the Kelvin wave generation area, a bit, we'll say, modestly stronger than normal, probably meaning no sign of the active phase of the MJO. All right, so now what is this? This is the forecast for the next week, plus everything that's been going on for almost a month prior to that. The blues are easterly anomalies, the reds are westerly anomalies. We want westerly anomalies. But this is also the whole planet on one chart, so we need to sort of parse out what is the Pacific and what is not the Pacific, because it's only the Pacific that we're really interested in. So the date line, 180 west, runs right up the middle of the chart there. Okay, the far West Pacific is about 135 east, so right there. And California is about 120 west. And this is only on the equator we're interested in. And then Ecuador is at about 80 west, so right about there. And you can almost see a seam in the picture right there. So the Pacific starts there, ends about there. The reds and yellows are westerly anomalies. So we see westerly anomalies. Here's today, right now, just in the past day or two, is trying to build into the West Pacific, where we had this big blob of easterly anomaly that's been in control of the Pacific. This would be the inactive phase of the MJO, moving from west to east. It's over the date line right now. Looks like it's forecast to hold for the next week as westerly anomalies try to get a toehold in the west side of the Pacific, suggesting the pending development or movement of the active phase of the MJO. And you can see it here from the Indian Ocean into the West Pacific. That's a good thing. All right, so let's go out 2 weeks now. All right, this is outgoing long wave radiation. Fancy words for cloud cover. Where you have clouds, that's where you have low pressure. Where you have low pressure, that's where you have the active phase of the MJO, and that's what we want. So, this goes out 2 weeks, 5 days at a time. South America, Central America, Hawaii, the equator, running right through the middle there. Okay, New Guinea, Australia, the Philippines, Kelvin wave generation area from 170 west, so right about just east of the date line, over this area to 135 east, 5 degrees north and south of the equator. So the blue is the active phase of the MJO. Today, trying to get a toehold in the West Pacific. So the previous chart and this chart are in sync. Building, according to this, the statistic model, filling the Kelvin wave generation area 5 days from now and 10 days from now, and then fading 15 days from now. But the dynamic model, and we'll sort of keep the statistic model right there too, says, well, the active phase is supposed to sort of try to get its act together over the next 10 days, but really not get a foothold, a good foothold in the Kelvin wave generation area to 15 days out. Difference between the dynamic model and the statistic model here, 2 weeks out. Of course, that's a long time and a lot can change, but we would probably favor this model here. A longer duration of the active phase over the West Pacific is better for producing Kelvin waves and for imparting energy to the jet stream. Next up, phase diagram charts. Basically, the same two models, statistic model, dynamic model, but a different way of looking at it. Okay, the MJO, active and inactive, move from the Indian Ocean, from west to east, from the Indian Ocean over the maritime continent, this is like Bali, that area, over the West Pacific, over the East Pacific, under the United States on the equator, right? Over the Atlantic, over North Africa, back to the Indian Ocean. So the heavy dot is where the active phase is right now. The further it is away from this circle, the stronger it is. So a pretty, say, weak to modest phase of the active phase of the MJO over the maritime continent today. 3 different projections from the statistic model say it being very, very weak in the West Pacific, or maybe moderate strength, but moving to the East Pacific or almost out of the Pacific and into the Atlantic per the statistic model. The dynamic model suggests the active phase crashing very weak like 5 days from now. Let's see, 1, 2, 3, 4, 5. And then building to moderate strength, holding over the West Pacific 2 weeks from now. So this is the detailed view of the charts we saw before relative to strength and exact position of the active phase of the MJO. Another component of the MJO is moisture, precipitation. This is an upper level view. The greens are areas favorable for precipitation, meaning the active phase of the MJO. The oranges and reds, the inactive phase of the MJO, and meaning dry air. All right, this goes out 40 days, so each panel is 5 days in duration. South America, Central America, 0 degrees, that's the equator right there. New Guinea there, dateline roughly there, you get the picture. Active phase trying to set up in the West Pacific, and this runs about a week ahead of what actually happens at the surface. This is up at jet stream level here. So active phase of the MJO traversing the Pacific and pushing through Ecuador into about June 11th. Then the inactive phase sets up. It makes its push across from, we'll say, June 8th through, June 26th. And then a second pulse of it behind that, but fading. And then another active phase setting up, we'll say, late June, early July. Here's the 1 month view from the CFS model. This is a pretty good longer range model. All right, whole planet on one chart again, date line right there. The far West Pacific, 135 east, so right roughly there. And Ecuador somewhere over about here. The blues are easterly anomalies. The dotted contour here is the inactive phase of the MJO, May 8th. Okay, so you can see the inactive phase of the MJO, developed here in the Indian Ocean, has been traversing through the Kelvin wave generation area and is almost out of it. Should be gone Well, the Kelvin wave generation area ends about 170 west, so within a day. And you see the easterly anomalies that it has produced traversing the planet as well. Now, the good news is the solid contours, the active phase of the MJO, it's in the Indian Ocean, but also trying to push to the east. Westerly anomalies supposedly building in the Kelvin wave generation area today, and forecasts holding in the western half of it for the next month. Strongest, though, for the next 2 weeks. And then this kind of easterly anomaly thing sets up again in the absence of any MJO activity as we get into, we'll say, mid-June, something like that, but not very strong. And then finally, the 3-month CFS model. Now, the past activity is down here. The future is here. And what you can see just by eyeballing this, there's the date line right there. Westerly anomalies. This is easterly and westerly anomalies. The yellows, westerly anomalies. That's what we want to see. Synonymous with the active phase of the MJO. Setting up in the West Pacific from now the whole way through the end of August. Hard to believe. Not particularly strong. Previous runs of the models had just suggested much stronger westerly anomalies, but still, westerly anomalies holding. But also interesting, there's like this brick wall. There's like a line running right here. Westerly anomalies in half of the Kelvin wave generation area. Easterly anomalies starting, just eyeballing about 170 east, so on the eastern half of the Kelvin wave generation area and filling most of the Pacific. This would be typically what you'd see high pressure ridge building in the Gulf of Alaska and holding there, especially as we get into the fall, drought into California. This is that typical kind of pattern where the La Nina pattern is trying to get dislodged out of the Pacific, but hasn't quite made it. It's just stationary and locked, filling half the Pacific, where an El Nino-ish like pattern is trying to get established in the West Pacific. Let's overlay the MJO. We'll get into a little more detail here. All right, so here's our inactive phase of the MJO, the dotted contour here, that's moving from the Indian Ocean, here's today's date right there, over the East Pacific. Here's the active phase of the MJO, just trying to get a toe in the West Pacific today, producing some westerly anomalies. And interesting, no real inactive phase to follow it, but another active phase right behind. The models have been consistently suggesting a pretty much nonstop active phase from now through the end of July, with westerly anomalies, the yellows, you can see it there, in control, but easterly anomalies over the East Pacific. And then even after that, westerly anomalies persisting, but this dividing line, I mean, you can just about draw a ruler right down there. So what's driving that? Well, we look at the low pass filter, and it's sort of a, where's generic high pressure and generic low pressure at? All right, and that's your El Nino La Nina indicator. So date line right there, these dotted contours. This is the high pressure bias. California runs right up through here. So high pressure was in control pretty much of all the Pacific this past winter. But you can see we went from 4 to 3 to 2 contours by about June 1st. That will even disappear. We'll be down to 1 contour. And that last high pressure bias contour just hangs on over the East Pacific at the end of the frame on August 19th. You do notice couple little dots suggest maybe a build back of that as we get into the fall. In the meantime, the low pressure bias, which has been pretty solid over the Indian Ocean, when you have La Nina, low pressures in the Indian Ocean, high pressures in the Pacific. When you get to El Nino, they kind of flip, or what really happens is the low pressure bias moves over the Pacific, and the high pressure bias back builds over the Indian Ocean. We don't see that happening. But we see a weak low pressure bias today filling half the Kelvin wave generation area. And look at this line right here. It's going to make it to about, almost to the date line. And everything to the right of that line is easterly anomalies. Everything to the west of it is westerly anomalies. We want to see this line move, at least fill 2/3 of the Pacific. If we saw that, then we'd say this coming fall and winter is going to be in pretty good shape. But we don't see that. Instead, we see this sort of halfway pregnant situation where, you got high pressure in the East Pacific, low pressure in the West Pacific, and a brick wall line between the two, and no real movement expected. All right, enough of the MJO, enough of El Nino, La Nina. Well, not completely, but we're going to look solely at El Nino, La Nina now, and we're looking at not the atmospheric component, but we're going to look down in the ocean surface. Subsurface temperatures. Okay, West Pacific here, East Pacific here. This is data again from the TAO buoy array, that series of buoys strung across the equator. These X's are sensors that are on the anchor lines of the buoys across the Pacific. Now, not all the lines are working. There should be one there. There should be about 2 or 3 there. There should be one there. But the buoys go out. The solar panels on them go down. I mean, it's a maintenance chore to keep these guys up and running. And to get to them, well, it's out in the middle of the Pacific, so you got to send ships out there with a crew, and they got to do maintenance, and it's expensive, and you get the idea. So you get partial data from this, and then you apply a model to try to fill in the gaps, because you don't have, even when everything's up and running, you're still not going to have all the data you want. But what we are able to see is 28. That's 28 degrees centigrade. That's warm water. It was locked at, where was it? Pretty far off here. I think it was 175 or even 180 west most of the winter. It now is moving off to the east, and even since last week it was at 155 west. It's now at about 153 west, suggesting warm water is moving off to the east. And that's typically what you see when you have a Kelvin wave in flight. The 24-degree isotherm, nice and healthy here at 140 west. It's about 100 meters deep and pushing the whole way into Ecuador effectively. That's what you want to see. During La Nina, warm water gets very shallow here in the East Pacific. The more warm water in the East Pacific you have, the more evaporation you have, and then the better the odds for precipitation for California in the winter. Now, absolute temperatures don't matter so much. It's the anomalies. Here we go. Anomalies, differences from normal for this time of year. The good news is, last winter, this was nothing but cold water here. Now it's nothing but warm water. 3 degrees centigrade above normal. It was down to 3 degrees below normal in January, February, something like that. This is clearly a sign of a Kelvin wave in flight from a westerly wind burst associated with the active phase of the MJO in February, and then another 2 of them that happened fairly recently. Anyway, warm water, not quite as obvious here in the West Pacific anymore, but pretty strong in the East Pacific. Kelvin wave poised to impact the Ecuador area within the next week or 2 maybe. We're hoping. We'll see. We've got another model here, a little bit more detailed model, a little bit more detailed data suggests, no, there's still a pretty good amount of warm water bleeding out of the maritime continent, Indian Ocean area into the Pacific, and Kelvin wave right here in flight. Ecuador is like right here. So the Galapagos, I think, are right about 90. So you see the leading edge of the Kelvin wave right here in the last little bit of cool water associated with what was La Nina getting squeezed to the surface by this approaching bulldozer of warm water. Once that happens, we expect water temperatures in this area at the surface. Remember, this is all subsurface, pushing this way. It's going to start bleeding up to the surface over the next, it's 3 months worth of warm water there, bleeding up to the surface, warming water temperatures at the surface, and maybe helping get us back at least to an ENSO neutral pattern. Sea surface height data from May 18th. We're just showing you that. We'll slide down here. So that is South America. So Chile would be right there. Peru right there. Ecuador, Colombia right in there. That's the Galapagos, the equator right there. Central America, Mexico, Baja. Where's Hawaii? Right there. You can't even hardly see it. And New Guinea there. All right. So what we see is the height of the ocean. All right, you strip out the wind waves, strip out the swell and the waves, strip out the tides. Is the sphere of the ocean surface higher or lower than normal? If it's higher than normal, well, warm water expands, right? So it creates a little bump on the ocean surface. If you have a river of warm water running under the equator, then you get a higher than normal anomalies along this whole area, which is clearly what we see. 0 to 5+ centimeters, the whole way from the maritime continent into Ecuador, which is a significant good step forward, seeing how all this was negative a couple of months ago. Again, just indicative that there is a Kelvin wave, a rather large Kelvin wave in flight, and theoretically starting to erupt along the coast of Ecuador as of right now. And here's a chart that sort of puts things in a time frame continuum, if you will, from May of 2020 to May of 2021. This is the West Pacific here, East Pacific here. The blues are colder than normal water. Oh, this is upper ocean heat anomalies. Fancy words for water temperatures, but, are the temperatures higher or lower than normal? Blues, colder than normal temperatures. The clear La Nina signal, which started back in April of last year and went through about March of this year. Then you see warm water building up in the West Pacific in February and March, driven by very strong easterly anomalies, easterly trades just blowing nonstop for months. Then all of a sudden the trades backed off and boom, Kelvin wave number 1 started making its way across the Pacific, and then and also driven by the active phase of the MJO, and then the second active phase of the MJO in the April-May time frame, second Kelvin wave in flight. They're all at about 90 west, which is about where the Galapagos are. We want to see this make it the whole way across the Pacific and then start bleeding to the surface. We think that is going to happen. But let's take a look at the ocean surface. You see a completely different picture at the surface. All right? South America, Chile, Peru, Ecuador, Central America, the equator right there. And what do we see? We see cold water, last little bits of cold water being squeezed to the surface along Peru. And out there's the Galapagos right there, south of the Galapagos. We see a thin little just patches of light warm water along the equator. Okay, a little bit of warming, though, going on between the Galapagos and Ecuador. Maybe that Kelvin wave. Now, remember, the Kelvin wave and all that warm water is below the ocean surface, down 50 to 100 meters, or 300 feet or something like that. It will impact the coast here, and that's what will force it up to the surface. And if anything, we think maybe some of that is happening right in this area right here now. But we want to see more of that in a much broader area. Right now, it's kind of a mix of, well, you see, so here off of Central America, we have warming temperatures, but that's just, lack of wind, the sun sort of beating on the ocean's surface. Okay, and south of the equator, we see a broad area of cooler temperatures, not particularly cold, just lightly cold, right? And it's sort of this dividing line. The equator, a little bit warmer, a little bit cooler down here. And then, of course, off of California, anyone that's been surfing the past couple of months knows that the northwest winds have just been blowing incessantly, driven by high pressure, La Nina induced, that high pressure that's just locked over the Gulf of Alaska. This warm temperature here, that's where the center of the high pressure is. There's no wind there, so that's sunlight induced heating. But this is all upwelling by the leading edge of that high pressure making northwest winds. Okay, so the remnants, this is the remnants of La Nina doing its thing in the atmosphere. We see the beginning of a Kelvin wave trying to maybe reach up to the surface here, but otherwise we just see sort of a neutral pattern going on over the important equatorial region. 5 degrees north and south, that's what drives everything. That is the global weather jet stream determiner or discriminator, is what temperatures are happening in this area. That's why we focus so much on discussing the MJO, because that's what drives temperatures, Kelvin waves, and all that kind of stuff. Sea surface temperature trend for the past 7 days, about it, and all we're interested in is the equator. Pretty much dead neutral, but this thin little red warming temperature line right in there. It could be just complete noise and nothing, but we're going to keep our eye on it because we expect that Kelvin wave to be impacting right in here. This is exactly the sort of thing you'd see as the leading edge of it approaches. Also notice temperatures are not cooling off of Peru anymore. They're pretty much holding their own, but there's no real warming anywhere else either, just a neutral pattern for now. Then the backed off view, pretty much what we saw before. A little bit of cooling off of Peru, not unusual. A little bit of warming here. This is our suspect area. Pockets of warming, but nothing either. I'd probably give the balance to it being cooler than normal than warmer than normal. So still hanging on La Nina remnants, waiting for the Kelvin wave to erupt, waiting for something to kick us officially. NOAA said we're out of La Nina, but just eyeballing this still looks suspiciously like the hangover from La Nina, and the jet stream pattern doesn't really look like anything other than some sort of La Nina induced pattern either. So we're waiting for a change to occur. Sea surface temperature index, the trend in the Nina 1.2 region. This is the areas right there by Ecuador, Peru, all that sort of thing. Just temperatures hanging 866 thousandths of a degree below normal, 3/4 of a degree below normal, and it's been sitting there for months now. So no big change in the Peru-Ecuador area. But in the official El Nino region, the Nino 3.4 region, this is the area south of California on the equator, almost out to the date line, you can see a steady, slow, upward progression of temperatures. Remember we said temperatures were neutral, maybe biased La Nina. Well, officially, what is that? 14 thousandths of a degree above normal. So about as normal as you can get. We got up to, what was this? I think it was 2/10 of a degree above normal here a couple days ago. But, it's sort of, I don't know if you could really say these are pulses of the MJO, but it looks very similar to it. We could actually go and try to map it out. But anyway, you see, go up a little, down a little, up a little more, 2 steps forward, 1 step back sort of thing. But temperatures about dead neutral right now in the official El Nino monitoring region. So what does the atmosphere think's going on, right? The atmosphere sits above the ocean. Evaporation is what drives the atmosphere. If ocean temperatures are cold, you don't get much evaporation. That supports high pressure buildup, and that is sort of the precursor to La Nina. The reverse is also true. If you have a lot of warm surface ocean temperature, that creates evaporation, that creates lifting, and that is what makes low pressure, and that can push you towards El Nino. All right, so the difference in pressure between Darwin, Australia, and Tahiti, not that these are like ideal positions, but people have been making pressure measurements here for 150 years or so. There's a very long record, and so they took all this data, sort of checked it out, quality checked it, and then built an index out of it, right? And if the index is negative, that means pressure is lower over Tahiti, which is roughly over the Pacific Ocean. All right. If the index is positive, that means temperature is higher over Tahiti than Darwin, and that means high pressure over the Pacific. Today, the index plus 6.68, so a little bit higher than normal over Tahiti. And you can go back and look. You can see this is very noisy. We were up at 25 at one point, 32 at one point, and then down to 20. So there's a lot of noise in the daily contribution. So you take 30 days worth of data, average it out, and that gives you a better indication of what's going on. Today, about the same thing, plus 6.35, and we're actually higher now than where we were back in late April, but that makes sense because we are coming out of the inactive phase of the MJO, so we would expect to see, in fact, we were up at 7.65. We're actually, the pressure is starting to drop, the index is starting to drop, and we know the active phase of the MJO is coming, so maybe we'll see this thing go back to zero here in the next couple of weeks. The 90-day average is the El Nino La Nina indicator, today at plus 1.82, which is almost statistically insignificant. We were up at 4.69 a month ago, and we were up at, before that, up at 15. So the trend is still going in the right direction, approaching zero, approaching ENSO neutral. In fact, here has been the trend. So we can go back 2 years. January 2019, we were in sort of a weak El Nino pattern. Not really, but just barely. Negative. So there's the negative numbers. Then in 2020, we started our steady rise of the SOI index into positive territory up to January of this year. And then boom, a big crash. Here is, you can see this is the active phase of the MJO. The rises are the inactive phase of the MJO. So here's our little active phase of the MJO. We're already falling out of it, moving to the active phase of the MJO, hoping this line at least gets to zero or down a little bit below zero over the coming weeks. But in general, we've been pretty much hovering around neutral, neither La Nina oriented or El Nino oriented. So that brings us to the sea surface temperature forecast from the CFS version 2 model for the Nino 3.4 region, the official El Nino monitoring region. And we are in May, so April, May, somewhere right around there. Actually, temperatures we know right now are dead neutral. So this is a little bit below the, what is actually happening today. The model suggests we'll be neutral in June into July, and then and that probably will be in sync with the impact of those 2 Kelvin waves hitting Ecuador, and then a slow fade in temperatures, but only to a half degree below normal as we get into the fall, and then rising from there. This is probably not going to be La Nina. It would be a ENSO neutral, and we think this is biased cold. Raise these temperatures up about 1/4 degree, and we'll be sitting probably about dead even for this coming fall and winter. The real question is, will high pressure break down in the Gulf of Alaska? Will we get precipitation into California in the fall, or winter? That is a big unknown at this point in time. With the low pressure bias over the West Pacific, though, that would at least suggest that we'd have a more normal storm pattern in the West Pacific this coming fall. So for right now, there is swell. Well, there's swell already hitting California. It's on the downswing, but another swell in flight for mid to late week. Nothing huge, tiny New Zealand swell. Rideable, waist, chest high, something like that. Nothing more. But a stronger gale forecast for the southeast Pacific, focusing on California, Central America, down into South America. Another potential we'll say reasonably sized. You notice we're not giving any of these significant class status. Has to be solid 3 feet at 17 seconds for us to do that, and we haven't seen that. I mean, yes, maybe Southern California, you could have said, okay, yesterday waves were significant class status at top spots, but certainly not up north. Just none of these systems really are making the grade yet. So I think we've had one significant class swell this entire summer so far. But we're keeping our eyes on it. Maybe we will eke out that status if the models play out as forecast. So potentially a swell for somewhere around next weekend or something after that. Longer term, the transition from La Nina continues to occur. We're ENSO neutral pretty much right now. We're looking to get for that to solidify. We're looking for 2 Kelvin waves to impact Ecuador and really warm up the equatorial Pacific. That will get us clearly in ENSO neutral status, and then that will help us into the later in the August time frame into the fall. The model suggesting beyond that, well, are we going to go to El Nino? No, definitely not. Are we going to be ENSO neutral? Yes, but are we going to have the hangover from La Nina cursing us all fall and into the coming winter? Too early to know. Will we get precipitation into California, meaningful precipitation into California for the fall and winter? Too early to know. We're hoping yes, but we're not holding our breath. Looks like east anomalies and high pressure ridge very strong at this point in time over the East Pacific, and only getting stronger as the high pressure bias sort of settles in over the East Pacific. At least it's out of the West Pacific, which means we could possibly get at least a normal or close to normal winter out of when we get into the fall and winter time frame from a swell production standpoint. All right, if you enjoyed the video, Give us a thumbs up. We'd appreciate it. Comments, always welcome. If you don't understand something, just put a comment in. We'll reply to you. We try to be pretty much on top of it. Don't let it sit. Sometimes it's a day or two, but we always get back to you. Comments, always welcome. It helps the algorithms, helps us make a little bit of money, but not a whole lot. Anyway, thanks for watching. We'll do this again next week, assuming we don't have computer problems. And go surfing, have fun, and stay safe. Thanks for watching.